Right. So thank you guys for giving me the time today. There was a question about the cutout. So that's actually my co-presenter, and that's Kyle Schmall. And he couldn't be here in person, but if you pay close attention to my presentation, I think you'll hopefully figure out what the deal behind the cutout is. Yeah. So hopefully at the end of the conversation or presentation, we'll see who can guess what the story behind Kyle's cutout over here is. So I'm going to introduce myself as Milan Shah, co-founder CTO of UpTycs, as Jason mentioned. But for this particular audience, I'll introduce myself mostly as a member of the Osquery community. Very happy to be here. And today I'm going to talk about Osquery and Docker. So as Jason mentioned, we are a company also building solutions around Osquery. And one of the things we kept getting asked by a lot of our prospects and customers and so on is, what is Osquery's application to the world of containers, right? So many of our people we talk to are looking at Osquery as a new disruptive type of technology, and they want to make sure that as they see other elements of technology evolving, that decision to go with Osquery is aligned with that. And obviously, containers and orchestration and so on is a big thing on the horizon. And we get asked this question quite a bit as to what is Osquery's sort of relationship with containers. So we started working on this a while ago, and it's still a lot of work in progress. It's not anywhere close to done. So I'll end this conversation with hopefully thoughts about where Osquery could go in the next few years as the world of technology evolves as we go forward. Yeah. So I'll start with a bit of a pedagogical, I apologize for this, but a pedagogical view of what Docker is. Yeah. And most of you probably already know it, right? So it's in many ways intuitively people think of Docker as sort of a mini virtualization environment architecture. You basically start with your raw iron, put a standard Linux type operating system on it, and you install Docker on it. And then once you have Docker on it, you run all these containers. Now what is probably very popular knowledge is a container is built of these images, right? So you get all these standard images. You can, let's say Ubuntu, you can actually layer images one on top of each other, and then you finally install your own application on it, and it's basically a container. And then magically Docker isolates these little containers without actually putting a hypervisor in there. Yeah? So somehow Docker is able to run these applications completely isolated from each other. Now what's really important and relevant, right, is that there is actually no virtualization really going on, right? It's each of these little containers are actually just processes on the host OS. The whole idea of a container is, from many perspectives, it's easier to think about it as a mini virtualization engine, but in practice, it's actually just closer to a installer package, right? It's closer to our Debian or RPM package. It's just a collection of files and binaries. That's what those images are. Yeah. What gets confusing sometimes is that most people will often start with the base image being like some kind of an operating system image. Yeah? So you can start with an Ubuntu thing or whatever. So people think that when they run this container, it's actually the kernel that from the base image that's running. That's actually not true. There's only one kernel. It's the host OS. Okay, it just so happens that it was convenient to package the entire Ubuntu, some older version, newer version of Ubuntu with their application, so that there's all these dependencies are taken care of. But it's actually not going to run the kernel that's bundled with that image. Okay, that's really important. When you run Docker on a machine, you can run other processes, and they're just essentially from a host OS perspective, they're really no different, logically speaking. Yeah. Now, what is somewhat different, the way isolation is achieved at the Docker level is through something called namespaces and through something called LXC. So LXC is a feature that was built into kernel, some older version, I think 2 point something. But it starts with just the ability to tag processes with something called C groups. So you just label a set of processes and say, well, somehow these processes belong together, and I'm going to tag them as container 1 or Nginx or whatever, yeah? And then with LXC, you can say this particular tag, I want to allocate only X amount of resources, X amount of CPU, X amount of memory, X amount of bandwidth, etc., to that container. So that's how you get this sort of this pseudo virtualization type of experience with a container. Yeah. A lot of the magic inside a container is achieved also through namespaces, right? So each container ends up with its own namespace, for example, /proc and so on and so forth, that belongs only to it. So it looks like it's running its own virtual container, but trust, the reality is it's just a standard process with a fair amount of sophisticated naming, namespacing, separation going on. Yeah. That was just everything I said in words, I guess. A lot of magic done with the standard processes, grouped together using labels, grouped together using namespaces, and then a kernel feature that actually allocates resources based on this namespace boundary. One other thing I'll mention is Docker itself exposes an API, so you can actually query it on what's going on in the world of containers and so on. So the first contribution that we made was a set of Docker tables. So if you go to Osquery.io and look at Docker _ everything, you'll see a bunch of tables that we exposed. That's just Osquery calling through this Docker API into the local Docker engine and saying, all right, give me all your containers, and then for each of the containers, the API supports things like list me all the processes running inside that container. Usually there's only one start process in a container, but that can of course launch children processes, so that you could have multiple processes in a container. You get statistics for a container. There's configuration information like ports, networks, volumes for a container, and you get metadata about containers. You can label containers and things along those lines, yeah? So you can get all this information from the Docker API that's already been hooked into Osquery, so Osquery is able to actually give you information about this. So if you're running a containerized environment and you can install Osquery on the host OS, you can actually get very good visibility into what's going on with the world of containers. Okay. Now, one thing that gets very tricky is, for especially trying to do intrusion detection, compliance, vuln management, and so on and so forth, you want to get at things like what sockets are being opened by these containers, right? So it turns out, as I mentioned earlier, containers are nothing but processes. So when a container opens a socket, it's actually the host OS that's opening a socket. So since Osquery already has process open sockets table, you can actually just query it to figure out what sockets are being opened. So if you want trying to do intrusion detection, and part of that involves figuring out what IP connections are being made by that container, you can actually just use the standard old process open sockets. Now, Alessandro from Trail of Bits added a very important field called net namespace to process open sockets. And what that does is combined with the list of containers. So if you look at the query over here where it says join it on the docker containers.net namespace, you can actually figure out which container opened which socket just using the standard old process open sockets table from the Osquery's support. Yeah. So now with the Docker container tables as well as things along the net namespace addition, column additions to tables like process open sockets, you can get a pretty complete view of what these containers are actually doing. You can use it to manage and do your normal security monitoring and so on and so forth with your container environment using Osquery. Yet another interesting idea that's actually a PR today, contributed by Facebook's Diptanu, relies on, I point this out because it's an interesting application of the fact that containers are again just processes. So what he did was he wanted to get at the file system inside a container. And more specifically, he wanted to figure out what packages are installed so he can then turn around and do vuln management, right? What vulnerabilities might be present in the binaries inside a container. Now, one way he did that was he just attaches, just like a debugger attaches to a process. Well, Osquery is a process, containers are a process, one can attach to the other, and as soon as you attach, you're in that process space. And then all the Osquery tables will actually execute in the context of the container. So all the files, et cetera, available to the process inside the container become available to Osquery. Yeah. Now, if you look at the debate, which of course we all agree with, it's kind of a curious technique, somewhat dangerous, right? If Osquery goes down at that point in time, it'll actually take the container down and so on. So it's not something we probably want to include in the core without a lot of careful thought and so on. Probably why it hasn't been accepted yet, but still goes to illustrate, the idea that a container is just another process, and you can use Osquery to do interesting things with it. Yeah. So bottom line is, the intuition that a container is a mini VM. So it's a mini VM. There's actually an operating system image inside. So we'll just run Osquery inside every container. Is actually not a good intuition for many, many reasons. The containers are designed to run a single process. Plus, if you run, you can typically run of the order of hundreds of thousands of containers on a single piece of iron. If you try to put Osquery in every container, you'd end up with way more Osquery running on your CPU than the actual services it's rendering and so on. And as we have seen, there's no need to do this. Osquery can run as a peer process to all of the containers. You just need one Osquery per iron, and it'll use the Docker tables and things like the net namespace fields in process open sockets, etc., to give you full visibility into what's going on your container environment. So at UpTycs, we have been able to use this to do things like intrusion detection, vuln management, audit, and compliance using the capabilities of Osquery directly by installing it on the host operating system. Yeah. One interesting use case is also resource management. So it's it's a standard dynamic, I guess, in the world of developers. So since resources can be managed, when you create a container, you can say this container should use X amount of CPU, Y amount of memory, and so on. In theory, you can really cram more usage out of your raw iron by running containers and optimizing the overall usage, right? But containers are developed by developers. And guess what? If you ask Kyle over here, hey, how much resources your container will your container need? He's going to say, yeah, I need 8 procs, I need 64 gigs of memory, I need all 100% of the bandwidth, and so on, right? Why would he want to shrink it down? So of course, at the operational side, you can use things like Docker stats to figure out, hey, how much is something actually using, and then optimize the configuration of your containers to really get more juice out of your server infrastructure. Yeah. So these cases worked today, and it was all going nice and smoothly for us. And then Kubernetes shows up, right? So Kubernetes in and of itself is just an orchestration engine. So the idea here is a classic microservices architecture. You develop all your components of your application as containers, and then you string them together, and then you use something like Kubernetes to say, well, I've got these 15 containers or 30 containers or however many you have, Nginx, Kafka, this, that, Postgres, etc., all stitched together to create my overall application. Please do run this whole unit, right? Oh, by the way, I'm going to give you these 15 servers to sort of manage and run the containers on. And Kubernetes will figure out, based on the configuration, which containers should run on which nodes and so on and so forth, scale things up and down based on load and so on. So it brings a lot of interesting features to it. From an Osquery perspective and HostOS perspective, nothing has really changed. There's an overall orchestration engine. Who cares, right? Osquery can run on every one of these nodes and do what I just explained earlier in my presentation. Yeah. The problem is now people like Google and Amazon and at some point Azure, Red Hat's OpenShift are beginning to offer hosted Kubernetes. So the idea is that it's, I guess it's a step towards pure serverless computing and so on, right? You don't, as a person, as an enterprise trying to run an application, you don't have to care about hosts anymore, right? You just say, here's my containers, Google, just run them wherever you want, as cheaply as you can. I'm going to pay you for containers. I'm not going to actually buy servers from you. This is fantastic. Makes things a lot easier. It takes a whole entire piece of infrastructure that you no longer have to manage. Yeah. Of course, the problem is How do you do intrusion detection? How do you do security? How do you monitor your containers and so on? The thing where you installed Osquery on is gone. Okay, so so this was why we were getting asked the question by many of our prospects and so on, saying, hey, we are thinking of using, or they are actually already using GKE, or EKS is not yet in full availability. It's in preview mode at Amazon, but people are beginning to make plans to run their containers in this kind of environment, and they're like, well, Osquery doesn't seem like a good idea anymore, because where are we going to run Osquery in the first place? So we started looking at it as to how are you supposed to, forget about Osquery for a second, but how are you actually supposed to monitor any of your containers in the world of Kubernetes, right? So Kubernetes has this concept of a daemon set. So a daemon set is just a container or a pod with the only special thing being that when Kubernetes, when you tell Kubernetes of a daemon set, it's actually going to run an instance of the daemon set on every node. By default, you have some control over where it runs, but by default, the intuitive idea is that, okay, here's a daemon set that runs on every single node that's in the cluster, the Kubernetes cluster, right? And the idea is to put monitoring stuff into this kind of a container. The textbook example that they will give you when you look this up is how do you run, let's say, something like Logstash in there, so you can collect all the logs generated by all the other containers running on that node. Okay. So, intuition tells us that, hey, maybe Osquery should run inside a daemon set. So we did that experiment. So we went to GKE, created a little cluster for ourselves. There's Kyle, by the way, so he did it. It's pretty straightforward. You go to workloads, you can say, hey, I've got a daemon set, I've got my other containers which do my application. And we created a little image with Osquery installed on it and ran it. Okay, so Kubernetes spins up this daemon set, Osquery starts running, and we very quickly say, hey, let's look at all the processes, right, on the node. But of course, it's a container now. So daemon sets are containers. When you do select star from processes, it will tell you, yep, you're running Osquery and pretty much nothing else, because it's running inside the container. So it can't see anything else. Yeah. But no worries over there. So what we said, well, the Docker tables that we built talk to the Docker API, right? Well, turns out the Docker API talks over this socket, var run docker.sock, right? Now, what we did was we took this socket from the host OS and mapped it and mounted it into the daemon set container, right? So now when the daemon set the Osquery running inside the daemon set container opens up var run docker.sock, it's actually opening the socket running on the host OS, right? So at this point, just because we did this mount into our daemon set, the Docker tables start working. So now when I say select star from Docker containers, Osquery is running in its own container, but because it is essentially making a call out to Docker running on the underlying host OS, it suddenly has visibility into all of the containers running on that node. Okay, so that's a good step forward. So at least from my daemon set, I know what else is running, what other containers are running on the same node, and so on. I point this little asset ID out, is the name of the daemon set in our world, because I'll reference it again in the coming slides. Yeah. All right, so far so good. So we just basically mounted a socket into our daemon set, and suddenly I get access to the Docker running on the underlying node. Okay, so that's pretty cool. But now the big limitation is, what can I really do? It's good to know what processes are running on the other containers and so on. But I really want to understand things like what files are being opened, what sockets are being used, because ultimately I'm trying to do intrusion detection, things along those lines. Yeah, so. The problem is those sockets and things like that are known only to the container that opened them, as well as to the underlying host OS. So not knowing a lot about how things work, we said, well, that's easy enough. Let's just mount /proc from the host into the daemon set. So that's what we did, and took a couple of things. We had to mount /proc into something called /op, just an arbitrary name, I guess. We mounted it at opd osq /proc. We also had to mount the pseudo terminals table into our daemon set, yeah? And I'll explain why, because a lot of sockets are, everybody has standard in, standard out, which usually point to an entry in dev PTS someplace, yeah? So we mounted these two things into the daemon set straight from the host, right? So the host operating system's proc is now mounted into my daemon set, but not as /proc, it's mounted as this other name, yeah? And if you look at the code for Osquery, how select star from processes works, or how select star from process open sockets works, it's actually just going through /proc, right? So all we did was we just basically cut and paste that table, called it host process open sockets and host processes and so on. And suddenly these start working. So now from inside my daemon set, I can actually get access to the sockets as visible to the host, which means all the sockets being opened by all of the containers, yeah? So that's pretty cool. So now we have all of these sockets that are opened by any container running as a peer of the daemon set, okay, on this node. Now one problem we ran into was, well, the process ID is the process ID known by the host, right? But when you call select star from Docker processes, the process IDs over there will be relative to the process the container itself, which will be different from the process ID known to the host. So what we had to do was write another table called host processes, which basically has all the processes that the containers themselves are. And now we have a matching on the process IDs and so on and so forth. Yeah. So put it all together, and you can see that if you just treat the world of containers as a set of processes with all this complex namespace stuff going on, these process IDs floating around everywhere, it's a matter of just mapping what's known to the host into your daemon set Osquery container, and suddenly you get a lot of visibility into all of your containers, yeah? Running on in your environment, even if it is in a hosted environment. Next steps, which I was hoping to get all this completed before this conversation, but this is basically where we are. So the next step is to actually get access to files, and as you can imagine, a container is a process, so where do you think its files live, right? The files live right on the host. They all live, depending on the file system, in use by the Docker engine. The default one is an overlay 2 file system. So all those files are actually kept in var lib docker overlay 2. If you're familiar with sort of copy on write type of file systems, that's basically what they are. So all those images that you build containers out of, they live as files in this particular directory. If a container were to write to one of those files, an overlay directory is created, and then the overlay 2 file system knows how to service the container's request for files based on whether it has written to it or whether it's still referencing the original file from the disk image and so on. Yeah. And the bottom line is, though, if you have access to the host and you can mount var lib docker overlay 2 into the daemon set, suddenly Osquery will have access to all of the files for all of the containers. Yeah. Again, these are all just files. If you do enough work, you can figure out what packages are installed. So an alternative to attaching to processes would be to go through the overlay 2 file system and then be able to figure out which packets are attached, or which packages are installed in which containers, and you can then do vuln management and so on and so forth. Yeah. Chris talked about audit D and the netlink sockets and so on. So again, we haven't done this experiment yet, but in theory, it should be possible to connect to the netlink D on the underlying host from inside the daemon set and get all the audit events and so on tables working as well. Yeah. So we just want to go through all of the tables and see how we can get them working from inside a daemon set. What's really interesting to us is the fact that initially we were kind of curious to understand what is Osquery's place in the world of containers. Now, one thing that's really happened is we have suddenly seen a lot of interest, because when people asked us saying, yeah, well, we could go with an Osquery-based solution, but we are really moving towards containers and so on, and there's all these purpose-built container security solutions, StackRox, Twistlock, Aqua, these are some big names out there that specialize in container security. But what's happening is most of these solutions rely on having a Docker plugin, Docker engine plugin. That's how they are getting access to the system calls being made by the Docker processes and so on, or the container processes, I should say, right? But once again, when you go to a world of hosted Kubernetes, there's no place to install those plugins. The Docker engine is owned by AWS, Google, Red Hat, and so on and so forth. So all of these solutions, architecturally, they become into a problem because they can't install the plugin at the Docker engine level. Yeah. So the reason we are getting this renewed interest, saying, "Hey, what's the Osquery story around containers?" is that it might be actually the only viable story for container security and monitoring as we go forward. Some of these purpose-built ones don't seem to work very well. The other trend we are seeing is that, as usual, nothing in the world is homogeneous, right? So very few people actually have 100% containerized applications and so on. They're mixed, they're transitioning legacy applications into microservices architecture. So some of it is working in containers, others is still on VMs and so on. So something that's purpose-built for containers only solves half the problem. So you can't really secure your overall application if it's only doing containers or if it's only doing a VM. So Osquery, with some of this experimentation we're doing, seems really well positioned to service that need, right? So if you have an application that's, some of the components are running on a pure VM, others are in container, Osquery can actually span across the whole gamut and give you a comprehensive view and a security solution for that. Yeah. So we thought this has been an interesting sort of journey for us. So on, yeah. So it's pretty much the end of the conversation. So I would ask if anybody had paid close enough attention to find out the underlying story behind Kyle's cutout over here. Any guesses?
It's a container.
Sorry? Okay. So it does look like everybody was paying attention because there's absolutely no hint at all in my presentation as to why Kyle's cutout is over here. What actually happened is as usual, towards the very end, I called up Antigone and said, "Hey, you know what? Since Kyle has done most of the work over here, I'd like to co-present with him. Is there any chance I can bring him along, right?" And if you've met Antigone, you can see the enthusiasm with which she treats everything. So it was fantastic to see her response. She goes, "Let me see what I can do for you right away," right? And within 15 minutes, I had a call back saying, "Well, I went and checked with the authorities at the Palace of Fine Arts. I'd never been here before, right? And they say, well, it's going to violate. If Kyle comes, the event is oversold or is completely sold out. If Kyle comes, it's actually going to, violate the fire codes over here." So I said, "Oh, really? Come on, right? One guy, right?" So I look up the stats on Palace of Fine Arts. I thought it was nice to end the conversation, end our session over here with talking about Palace of Fine Arts. And Jason started the conference by talking about Palace of Fine Arts. Right? So I looked up some stats. 120,000 square feet. There's 126 of us, according to Jason. Right? That's close to 1,000 square feet per person over here. We have 40-foot ceilings. Yeah. So really, I was like, "Antigone, really, you're telling me this is a fire hazard?" And she goes, "Yeah, they take their fire codes really, really seriously." And I was kind of skeptical, right? And I said, "Really?" And but I became a believer when I came here the first time, because as soon as you enter, you see this thing. There's the biggest thing out there is the fire alarm control panel. So clearly they take their fire codes very seriously around here, yeah? So I thought about ending a security conference with a hack. You got to hack at a security conference, right? So I opened the door up, and today, as you can see clearly, I took a picture. It's right here outside as soon as you enter. And actually, a security guard actually did come up to me and say, "What are you doing?" So I put my phone in, and I said nothing. And he looked at me, and clearly the UpTycs logo carries some weight around here, so he let me go. He didn't ask me a second question, right? So I took this picture. Yeah. So the story behind Kyle was when I asked Antigone, right? I said, "Well, if you can't come, can I bring a cardboard cutout?" And Antigone said that's going to be really funny. She checked with the authorities. They thought it was funny. They said, yeah, bring one along. That's perfect, right? I actually asked them, saying it's a cutout that meets, I think it's called the NFPA, the National Fire Protection Agency Code 704. It's a 140 rating. Is that going to be okay? And they said, yeah, don't worry about it. 140 rating is the rating for butane, by the way. So I said, that's going to be fine. And then I came in yesterday and I saw that corner is kind of dark. I said, well, can I put a lamp in front of it, maybe like a 500-watt lamp in front of it. And they said, yeah, not a problem, yeah? So clearly an organization that cares a lot about its fire codes. I was able to hack it. Don't worry, that's an LED, so it's not really 500 watts, otherwise that thing would have caught fire. Luckily enough, actually, we have a tin roof over here, so if there was a fire over here, in spite of the 120,000 square foot space, we would actually be quite vulnerable over here, yeah? So want to end the note with, security problems are probably not related to Docker containers. Real hackers are doing something a lot more simpler. So with that, I want to say stay vigilant, happy hunting, and thank you for having me here.